we are super excited to welcome you to the very first session of first ever Super Summit. So welcome to you all. I am Sam Alexander. I am a software engineer at Catch. And we have been talking quite a bit about architecture patterns, especially related to microservices, which we use very heavily at Catch. And we were thinking a little bit about how to continue this discussion at the Super Summit here with all of you. And the format that we came up with was to invite a whole host of people who are much more qualified than we are to help discuss this topic and share their stories and perspectives around design patterns and microservices and whatnot. So thank you to Bryce and Nathaniel and Max and Sid for being here. I'll let you all introduce yourselves more fully in just a second. And just a quick overview of what we're going to be doing here. So for the first couple minutes, we're just going to set the table stakes around what microservices are, just general design patterns. This is answering the question of what, and then we'll get more into the why, the how, with the whole panel here. We're going to have, most of the time here is going to be chopping it up with all of these fine folks, and then we'll open up at the end for audience questions, anything that you guys are going to cut out as we go. So our general objectives here, I think one of the things that I am most excited about being here with people from all sorts of different companies is to hear the stories and patterns of building out all of the tech stacks across the Hive. Certainly there's some stuff that is the same, there's some stuff that's very different. I'm excited to hear all of your perspectives. I know we've talked a little bit in advance on some of the ways that you guys have built out things, but I'm excited to get more into that. We're going to talk some more about do's and don'ts from in-field experience, some trade-offs in architecture patterns, and perhaps this will somewhat serve as an advertisement for some of the future sessions that we have going on here today around testing and observability and local development and deployment of infrastructure. That's part of the reason why we're doing this early on. I think a lot of the topics that we discussed today will be discussed much more fully in future sessions. So that's generally the agenda here. And we want to start just very broadly on talking about what is the problem we're trying to solve when we are designing complex systems. So there is some business use case that we are trying to address. And we also want these systems that we build to be reliable, performant, testable, and maintainable. Now, I would say that this is almost certainly reductive on what these overall patterns are, but broadly speaking, this is what we're aiming for. We'll talk about more on the how we get to this in a little bit, but this is generally where we're aiming. And the first thing I know you guys all know in this audience, everyone has an intimate understanding with monoliths and microservices and what those are. But just to set the table stakes again, monolithic architecture revolves around a single unit of code where all the application logic is in one code base, whereas microservices are a whole bunch of different units of separately deployable code with some communication mechanism between them. So perhaps we'll come back and build more upon this model of what these are, but certainly we're going to talk back and forth on the benefits of microservices versus monoliths and monoliths versus microservices, and this is just a general grounding. You guys all know this, so we'll breeze past this. Sujung, do you want to dive a little bit more on microservices?
Yeah. So just like a couple. Can you hear me? Yeah, just a couple things that you might have seen in the field. Again, this is not an exhaustive list, just priming the pump, what we're talking about, microservice design patterns, one database per service. So you have a single data store that is not shared across different services. That way you can scale them differently, and you have like a very clear domain model, like what this entity does and where its data is stored. Might see command query segmentation type models where you have separate service that is running your queries. So these are the select to your databases, select statements. From the ones that are mutating the data, you might separate that out to different command service. That way, if you need to scale your services differently, they're separated. They might have different security type permissions, authentication. You have the concern separated, scaled differently. Another pattern that you might see, we use at Catch as well, API gateway. So all your services are running, and they have a single point of entry through a single API gateway. That way, you can have that as like your auth layer, and the services can remain independent. Similar to, or yeah, the last one I have here is just simple event bus. We have that at Catch as well. In order to have the microservices talking to each other, you need you can use event bus to have service A publish what messages he wants, and then service B and C can talk to it or subscribe to those messages. So just a couple like design patterns. We'll learn tons more from our illustrious panel, but just kind of setting the stage. What are we talking about? But without further ado, I wanted to go ahead and let our panel introduce themselves. If you are able to introduce yourself and your company a little bit, since all of us, this is the first session, so hopefully you can tell us a little bit about the business use case that your startup works in, and then some simple description of your architecture. You can just get on the line.
All right. Well, hi, I'm Bryce Cottom. I'm the principal architect at Spectrum Labs. At Spectrum, our mission is to become the leaders in natural language understanding in contexts where civility matters. And so what that means right now is our core offering is a set of classifiers and inferencing that detect toxic behaviors like child sexual grooming and harassment, racism, things like that. And our architecture is probably a little bit closer to Microservices, but we'll get into all kinds of details, I'm sure, as things go on. But excited to talk about microservices and modularity.
Okay, I'm Max Matthew. I'm a co-founder at BoomJam. It's hard to go from toxic content. We're building software for musicians so they can collaborate. Like no song out there is done by a single person in the corner. There's always multiple, people's involved in those, and it's kind of a mess right now. There's no single tool. Like imagine how developers were doing code back in the day before Git and GitHub and all that. Like there's no versioning. There's nothing. It's pretty bad. And so we're trying to solve those problems. Like there are many problems all the way from when they are building the song, and basically it would be like you guys are writing code, like how you collaborate on that, but also all the way down to what you call deployment. But for us, like pushing the songs to Spotify and keeping track of performance. We're getting started, but we also do a lot of microservices, and we'll get into that. But yeah, that's what we do.
Hello everyone, I'm Sid. I'm an architect at Habu. So Habu is a data collaboration platform that works across distributed data platforms like lake houses, warehouses, Delta lakes, whatnot. Currently, our architecture has got it's a multiple layers. One is the Habu console, which is the control plane wherein the customers log in, define their define their business entities. They will define their data sources, data connections. They will build some questions, and then we have a distributed compute layer, which is kind of the brain of an engine, wherein we run jobs on Apache Spark, Snowflake. We do connect with different walled gardens like LinkedIn, Amazon EMC, ADH, whatnot. On top of that, we have orchestration layer, and then we also give customers Habu Intelligence, which is our visualization layer on top of the insights. Our complete infrastructure runs on Kubernetes on Amazon. And then I will talk a bit about how we do microservice and how we could have done it better.
Hi, I'm Nathaniel. I'm the CTO of Sturdy. Just the quick, not even elevator pitch, but a couple of sentences on Sturdy. Just so you have an idea, we take customer communications for B2B SaaS companies that they're having with their customers through their services or support organizations, capture them in one place, which is Sturdy, and then signal through NLP on the important things that are going on in those conversations. And the idea for that comes from running what we think was a pretty good support services organization in a previous company, and realizing there were things you could do to make that happen that weren't obvious to everyone, and we thought we could sort of encode that into a product. So, and let's see, I would say we're not really we're not microservice based, but we're somewhere in the middle between that. We're definitely not monolithic, and we're not microservice, somewhere in the middle. I like to call it mini service, something like that. I don't know, service, and more on the messaging side for communication. So we can talk more about that.
Awesome. So we wanted to dive in a little bit more about, it sounds like you guys all have some form of modularity in the way you guys build systems. Some of it is much more strictly microservices. Some of them, maybe less so. We wanted to dive in a little bit more about how you think about breaking down the business problems into these modular units, and what the patterns that you use are for that. So maybe go back down the line and dig a little bit more, if anyone wants to take it first.
Yeah, so the most important question. So the most important question before deciding, whether you want to embark on the microservices journey is that, first you have to decide that is your company big enough that you have clearly defined business entities modules in your system, right? Wherein you have clear identification of your bounded context first. Second is, let's say that you have decided that you have well-defined bounded context. Then the next question that you should ask is your code base large enough that it can be it can be broken into different modules? And then the last question that you need to add is that each of these modules, can they be independently deployed? Can they be independently managed, maintained? If the answers to all these questions are yes, that is when you should even start thinking about microservices. Right. So I would say, because not everyone is Google, Netflix. Right? If you have deep pockets, if you have clearly defined organization structure, wherein that even if you create a microservice, it is like a baby. That has to be groomed. Spinning up microservice on your local laptop is the most easiest thing to do. Right. But the actual part to production it takes. Right. So the monitoring, observability. If you have clearly defined organization structure that can kind of babysit, then yes.
I think we'll definitely touch more on the monitoring and observability as we go. More just general thoughts about breaking down a problem into microservices.
Thank you for waiting. 2 minutes of me yelling for nothing. Okay. You heard anything in the back? Okay. Okay.
Just motivation to get you to come.
So there's a risk of premature optimization with microservices, and so you need to kind of have your shit straight to start splitting out. Otherwise, you can have higher costs down the road.
I think from my perspective, we're still really, really small. Our services are just containers, and so and they talk over. Well, they're either scheduled to do something like a container for doing alerting, or their message to do something. Something happens and they do something. They pick it up off the message bus, right? But we have a monolithic repository. We have one database. So we're still in the early stages. But to me, it made a lot of sense to get. I've worked in a fully monolithic code base that was a big product, and it was not good. So I wanted to build in the template of where these things should be separated out. And it's all Python. They're separated essentially by the hierarchy of their, Python libraries that they're in. But some of the separation, but not the maintenance of multiple code bases or releasing artifacts and things like that, which will follow on directly from what we've started with. I hope. We'll see.
So our journey's been, I'm really big philosophically on modularity, single responsibility principle, separation of concerns and things like that. So I think one of the first steps in preparing to be ready for microservices, even if you don't deploy in separate containers, is code modularity. And we happen to be primarily Scala, so you'll hear me say plenty of JVM stuff. So like class path separation. There was a comment earlier about like, oh, I was writing to this database because it was there. If you have large code base that isn't modular, that happens to bring in some dependency, let's say Spark, we'll come back to that. And you, in some code that has nothing to do with Spark, you're using a Sparky thing. Then, yeah, Sparky thing. So that becomes really, really hard to break out. So even if you're not deploying and you're going to make API calls between services, having modular code we've found to be very powerful. And one of the points that I think enables us to do that is our amazing infrastructure team and how easy it is for us to deploy individual artifacts to our repositories and the Artifactory and stuff like that. So an example of this is one of the first things that I did when I came to Spectrum, that was write a big Spark job to do inferencing at scale. And we had a bunch of classifiers, and we wanted to run them all over all this data and see what happens. And I was kind of religious about the inferencing code and logic that I wrote having nothing to do with Spark. It had no idea. And turns out that library that does the inferencing powers our API today. And so we're in a position where we can simulate what our API would do with a back-end job having the exact same business logic and inferencing output. It's really powerful.
Thanks. Yeah, some really interesting perspectives there. Some things that I kind of picked up is it sounds like there's like this like Goldilocks where you have like too much microservice too soon can be a real pitfall. So I was just wondering if you guys, I think a lot of the companies at Superset, as they're starting out, do you have any advice? Like if you were to advise like starting out brand new, like what would you say? More microservices, less microservices?
Well, I think one of the decision points that I consider first is resource consumption and volume. So if you have a part of your business logic that is, handling all of the content, and then parts of it that are just handling some downstream part, as a really lame example, then the part that does most of the logic is probably consuming more of your compute. And you may need to scale that up, but not other parts. One example that we had in practice was we do NLP, and there are embeddings that we have. So we convert text to vectors. And those vectors can get very, very big. And so that's very memory intensive. And our inferencing is very CPU intensive. And so if you scale both of those together, it gets, what's the word? Expensive. So cost is probably the first thing that comes to my mind. If you have to pay a ton to deploy a monolithic thing a bunch, that would be a really good motivator for breaking it up in along the lines of resource consumption.
Yeah, I mean, cost is obviously part of it, right? Even though we have deep pockets and try to spend all that money, the one part of this is you also have as you scale, right? Like you want to kind of like find the right type of machines to run it, maybe, right? Like if you're all Kubernetes, like who cares? But like you have to specify the pods and all that, right? And so if you keep scaling up because one of them needs CPU and the other needs RAM, you just like keep having too much resource for everything, and that increase cost, but also scalability, maintainability. You have more machines that you need. Another thing that also is important when you split those out, sometimes it sounds like easy to split out. If you have dependencies, like I don't know, you're sending a mail to SendGrid or whatnot, like you don't want to be in sync with your code. You want to have some message bus or some queue in the middle, because if SendGrid is down, you don't want to send back a 500 just for that, and you want to be able to retry. And guess what? Sometimes they have things happening, and you want to retry. Another thing that we have typically at BoomJam is we take audio files, right? Those can be big. We have to process them. We want to convert them so they play in all browsers. So yeah, we generate some MP3 with high quality, high CPU, some RAM. If we were to do this real time when people upload, yeah, we wouldn't go anywhere. That the API gateway would have to scale up all the time. So we have like separate services just because, as you mentioned, they have different needs. But sometimes you also have that dependency on other services, or you want to retry, you want to decouple. Essentially, we want to start decoupling your services. And so those are the first points that are kind of like the easiest one to identify. When it gets tricky is when you're like, okay, well, so I have this data model, like say files, and I have this data model like users. Is this one service? Is it two services? And this is where starting with code modularity, as you call it, that's the right word. Like, don't try to mix them up. Like, if you can have your functions and your code well structured, it's going to make that code easier to split out. It also makes it easier to test separately, but also makes it easier to split out later on in microservices.
Yeah. So I would say microservices were introduced not to solve technical problem, right? They were kind of introduced back in 2013 to solve an organization problem, right? So if you follow Conway's law, that says that if there is an organization that is producing a design, it would produce a design that would kind of mimic that company's organization communication pattern, right? So that means that if in your organization, if you do not have a clear separation of ownership, right, and let's say that if you are not truly embracing DevOps culture, then it is quite difficult to introduce microservices and kind of maintain it. For example, at Habu we do have a flat organization structure, right? So there are almost 10 to 12 engineers. We have around 25 to 30 microservices, right? Now what that means is that even if I have to divide that microservice into one single engineer, every engineer would have to maintain at least 2 microservices, which is not possible, right? So yeah, so I would say before even thinking about microservices, get your engineering organization structure in place.
Yeah, I just want to come back to the two things that are most important to me, I think, is modularity and decoupling. I mean, that's the big thing. And like I said, we don't have microservices maybe in the strictest sense of microservice, but we have a template for that, and that gets everyone sort of, I hope, right? Because we're not scaling it yet, but gets everyone thinking of going in the right direction, that's the direction you need to go. You're going to need to go, and we even get benefits out of it now without a whole lot of extra effort, I guess. Oh, and yeah, I was gonna mention previously too. One of the reasons I kind of picked up on this session was someone in one of the very initial Super Summit meetings mentioned, well, do you even is it even the right thing to do microservices in a startup or whatever? And so I think that's something that you just have to weigh. When is the right time? That's probably the third most important thing, or modularity, decoupling, and when is the right time to move it forward and toward real microservices or whatever that is.
So I think I'm hearing very similar patterns here of starting off initially with a more monolithic approach, less containers, less cost, and then breaking those out into microservices as you go, as your organization grows. And I think this got touched on a little bit, but I'm curious to double click a little bit on when you're building a monolith type service that in the future you want to break out into microservices. How do you think about that? And I think everyone mentioned modularity here. But I want to get a little bit more tactical with examples on how you guys think about that in your setups today.
I'll start. I think when if you try to come up, and I can't really speak from experience at BoomJam. I joined, there was already microservices, so like, well, what the heck? There's a lot of code. It's already split. Let's keep those because some of those boundaries were right. But for the most part, you're going to start and you don't know what you don't know. So those splits you're going to have to make, like, if you try to make them too early, they're going to be wrong. There's some easy callouts for like user stuff, like, authentication is different than account data, so you can split those out, right? But this might be the only one that is easy. Then the rest is going to depend on like user feedback, on like market fit, whatever you're going to get back. So the way you can write your code, for instance, if you like, even all the way on like querying databases, right? If you do ton of joins trying to optimize for performance because you're making fewer queries and ton of joins, those are going to be a lot harder to split out. So try to think about like, okay, maybe 2 database calls is a better way of doing this. You obviously want to get that into control. You don't want to have 100 database calls per API call. That would be bad. But there's a place where you're like, okay, those two things are kind of like very different, and that the chances are going to be split out. And so that means in the way that you write your code and you structure your files, it's not like the monolith doesn't mean like it's one folder, tons of files, right? Like you have subfolders. You know how to structure your code, right? Think about like we're doing JavaScript, so we don't use classes. But if you use like a class-based language, like you don't put everything in one class, everything static, right? You think about, oh, this is my data model. This is where like something I want to instantiate. This is those folders I'm going to use. This is a naming. Well, all this applies too. And so if you start like mixing some of those data models, like you'll see this at review, like, hey, what is it's this function is called get user data, and you're pulling some notification shit. Like that's not the same thing. And so this the same way you would see those during a code review, and like those are not the same thing. You can start building this code this way, and you're like, okay, well, those are two separate things. Doesn't mean you once those are split out in separate functions, it's easy to refactor and be like, okay, well, those things they go together, and I'm create a file, and then maybe at some point your folder structure become your microservices structure. I think that's my perspective.
Yeah, so a point on modularity that I wanted to clarify is that if you make your code base modular, it doesn't necessarily mean you need a repo per module. Depending on your deployment capabilities of the platform you're working in, and happens to be JVM, we have one repo that has something like 10 or 12 modules. They're very related, but I wanted to separate class path for them. And so you can take like this little part, or you can take one of the bigger parts and leverage it. So you can make a single repo modular. And one of a concrete example to drill down and peel back layers of the onion is that one of the pieces of modularity in our inferencing is pre-processing. So we do some kind of text cleaning and strip out punctuation and maybe correct spelling or something sometimes. All right, that all lives in the Spark job I mentioned and our SaaS API, but data science, when they train, they want to use that same pre-processing so that they know the data that they're training on has the same prep that our production data is going to get when we do runtime inferencing. And so this preparing pre-processing code is not a microservice in our architecture that we use in our API or our Spark job, but we wrapped the library, very simple library, in a very, very thin gRPC wrapper, and now it's available for the Python connectivity with data science and things like that. So it's not necessarily that you need to say like, oh shoot, a team needs this piece of modularity. I guess we're making it a microservice that we have to call at runtime. That can kill your performance, but this happens to be very beneficial for us to be able to reuse the same code.
Yeah, I think like for us, an alert container is a pretty obvious, single use container. We know we're going to have to do it. We know it's probably going to have to scale. It's a good place. And again, we're still putting templates in place in a lot of ways. So we have a handful of containers. And we have one repo, but we have in Python you can do it's similar to class paths, I'm sure. I don't know exactly how that works, but you can do namespaced submodules. So we can move those at any time into a separate repo and create artifacts off them, version them differently, whatever we need to do without, with a little bit of a search and replace maybe somewhere, but basically they can move anywhere. So it's really setting up for us. We're still at this sort of setting up stage and thinking about all these things that we're all talking about, getting them in place and ready without the burden of going the whole way, maybe.
If you're starting fresh, right, so without even thinking about microservices versus monolithic, the way you should do it is you should look at your business domain. You should try to break it into different modules, right? And then you should always look into the dependency between modules. So for example, let's say that you are building an application on top of Java, let's say example, right? So first, be it microservices, be it no microservice. First, you should invest into your shared cross-cutting shims. That means that you should build something for your logging, monitoring, authentication, security, etc. This will become your shared shim. Now, tomorrow, if you think about moving this into a separate microservices, it is possible because that tier, which is your tier 0 module, can be easily peeled out into its own microservice. On top of tier 0, you should think about your common business objects. Right? Let's say that you have something for a user service, organization service. So to begin with, you should just create them into a separate modules. In Java, they can be easily built into a user.jar, a profile.jar. On top of that comes your application objects, right? So depending on what each company does, you should have different application modules. And now if you try to build your entire system using any CI, right? It could be Bazel, it could be Jenkins, it could be anything. If you have proper modularity, right? You will ensure that your shared libraries get built first. Then your common your common libraries will have a dependencies on your platform libraries, and your application libraries would have dependencies on your common library. That way, you have never broken down the dependency between your modules. Tomorrow, if you feel like going into a microservices, then it is quite easy to just peel away that module, which was a different jar, and then you can add it into a different microservice.
Thanks. Yeah, we're getting some really good advice on what we should do. Kind of along those lines, I was interested in how you've built out or talk a little bit about security and authentication across the microservices and any pitfalls that you've seen in the past that you could learn, or others can learn from mistakes.
I can go first, yeah. Yeah, so when I joined Habu, there were close to almost 42 microservices, each of them doing a TLS, each of them doing MTLS between them, each of them were passing around JOT tokens for the public key, private key decryption, right? So it was a mess, right? When we took a step back, so then we thought that, do we actually need such difference in depth between our east-west traffic and our north-south traffic, right? So then what we eventually came with is, so currently any traffic that comes into our VPC, right, which is the north-south traffic, that kind of goes through a public ALB, and that is where we will completely offload the TLS, right? That is just to protect the internet traffic, north-south traffic. Now, once you are within your own, let's say Kubernetes, right? Now, any traffic between the services, which is the east-west traffic, for now we have completely removed TLS from them. That is because we are kind of okay that if there is something wrong, and if there is a let's say an intruder hacker who has actually tapped into your VPC, that's a bigger problem than not having TLS between your services within your VPC, right? So now what we have is for any east-west traffic communication, we have we still have MTLS, and we are thinking of introducing something called as a service mesh like Istio Linkerd. That will take care of your search provisioning of your MTLS headers, whatnot. So in short, we are trying to decouple our applications to not think about TLS, MTLS. It should be a sidecar. It should be it should be a proxy pattern which is completely decoupled from your application.
Yeah, I think it was very similar. Right? Like we consider as soon as like anything coming from the outside, this is where we have the TLS endpoint, and then everything inside. Like yeah, we don't have to, you don't need to be too crazy about that. If someone is inside, well, they'll be inside anyways. Like not just something that happened at BoomJam, but there's past company where like it was pre gRPC and proto buffers and all that kind of stuff, and so all those microservices were talking through JSON HTTP. Not the greatest performance, as you can imagine. And so one of the issues that I had was like, oh, well, it's a lot of traffic internal to those nodes. We need to switch to HTTPS. And so they started to work on basically having like no trust, not trusting any other service making a call. And well, guess what? The performance was so bad. They were like, yeah, we have to stop this. So we basically had to revert the whole thing to just be plain HTTP. I left before gRPC was a thing. But the part of the other part of authentication is not just like crypto side or HTTPS TLS. From our perspective at BoomJam, you have like who can log in, right? Like that's basic. Like and if you have an organization base, like people are in a company, like more of a like B2B product, people will be part of a company. So like, hey, they have access to this, access to that. They have these specific roles. In the product we're building at BoomJam, people may have different projects. And so for each project, you may have like on one of them, you have these rights and the other, you have different rights. So we have basically the need to ensure that a single API call is valid for that person, for that project, for that resource. And so that makes like, some of those checks a bit harder to do. And so what we did was instead of doing this at the tail end at the microservice level, where you have to pass all this information, who's the person, and check that, and every service has to build their own checks and balances. What we did was to say, okay, well, the gRPC service is, like that microservice is a glorified access to the database. We may want to be able to reuse this to build support tools, right? Like some call support and be like, hey, I deleted that file by mistake. Can you put it back? Like we don't want that to be done by hand in a database or something different. So we want all that to go through our gRPC service. And so we put all this logic of checking access, right, and all that in our API gateway, the same way we would check OAuth 2 access for a token. And this way, as soon as we're inside, like, yeah, well, that call is made, and we trust that call that it's the right thing. So potentially risk might bite us back down the road. But for now, this has given us the most the best ROI from a complexity versus value.
So we're running a little bit short on time here, and I did promise that we'd open it up for the audience here, and we probably have time for one question. So if someone has something particularly juicy from the audience, the pressure's on now. So,
You said name your microservices well.
so do you have recommendations on naming there? That's always a fun topic.
I don't have any recommendation, but then I would say, names are something that should stick to you. Names are something that should be easy for you to refer to, right? So, just an example that if you have modules, if you have services, try to name them, which can be easy just by looking at your service name. You should easily relate it to some module like authentication service, data in service, scheduler service. Do not name them, something like Harmonix, Peak and Mix, Bucolic, whatnot. Fuck this.
So Sid, what should Kubernetes be called?
See, Vivek, a Kubernetes is an open source project, right? So the difference is that it had to be named, right? But within your company, I would say.
So the authentication service that talks to the other service to get that data, that's my name?
I didn't get your point.
If you name the services based on the function they're supposed to perform,
Yeah.
that could get really tricky, no?
It will actually so that also depends on your modules, right? So how have you broken your system into modules? right? If you have broken a system into micro functions, then then naming would be tough, right? But if you have things like authentication service, profile service, user service, org service, right? That way you have so the bounded context of it, right? Anyways, it is subjective, but that is just a recommendation because I have suffered with those names.
One thing we can all agree on: if you start naming your services with the name of the company, it's a mistake. This is our issue. All our repos are one. I have the name, all the microservices, and we're about to change the name. And I guess it's gonna be an inside joke forever because I'm not renaming all that shit. But yeah, don't put the name of your company inside. You're gonna pivot. You're gonna change the name 2-3 times in the first 2 years. So if you're starting now, give them simple names. That's don't put your company name in there.
Well, I totally agree that the obvious names make it easy for somebody to onboard. I gotta say, it's kind of fun to name systems silly names like Trogdor. We have one named Trogdor. Mordor, blah, 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 stuff. Some of them are kind of cool, a little theme. Culturally, that can be kind of fun, but it does suck for figuring out what the hell, what does Mara do?
Well, but isn't that what
That's
the
our
README
SaaS API input.
Isn't that what the README is for?
We do have pretty good documentation on this in reference sheets, and then everybody that has been there a day longer than you knows what the hell they are. So it's not all that hard to find out, but it can be kind of fun. Have a theme.
Any quick questions from the crowd here?
Hey, so my question is just basically like emphasizing on communication between microservices, like kind of interfacing between them. How do you kind of decide like how you're going to design, like the design for what kind of like how they brought it over like DB per service or like an event bus? How do you kind of decide what kind of communication kind of method you're going to use to interface between different microservices?
Yeah, so I think, well, I'll start at protocol. All of our communication, not just internal, our front end too, communicate over gRPC. And you should go to this guy's session on gRPC in your web app to find out how you can make that awesome. So that's really nice for compile time checking your inter-system communication. The decision point that I come to, or at least the first one that comes to mind for, is it a direct RPC call, or are you dropping a message on Kafka and somebody subscribing to it, generally boils down to how immediate the response needs to be. If the system dropping a message on an event bus needs the answer before it can reply, you probably shouldn't be using an event bus. You should be making an RPC call. But if it's just a notification like, hey, I did this thing, other people subscribe to this, go do it. If those are asynchronous, then over a message bus can be more scalable and allows you to do rolling restarts, and you can have downtime for one service that doesn't kill another one, stuff like that. So the immediacy of the response is the biggest factor for me.
When I joined BoomJam last year, they had used, there's a way you can do some direct gRPC call to have everything go through a message broker. So everything basically like you have an API call, it sends a message, and then something picks it up and sends a message, and everything is over a message broker. I knew this existed. I was almost excited to look at something like this. It was a freaking mess. Like when something fails, like in terms of observability, what's happening with this initiative, when everything's working, it's great. But when something was happening, there was no way to trace properly because like you're losing the stack trace, you're losing all of that because everything completely synchronous. And so you look at this and like, well, guess it failed. And so we basically rewrote the entire backend to stop having everything go through a message broker when it's something we want to do synchronous, when we want to actually like return a 500 or 400 synchronously, then it's a direct gRPC call. As soon as it's asynchronous, like trigger reindex in the search engine or whatever we have to do, it's completely asynchronous. Then we use message queue in the middle. That's been the rule that we've used, and that's been working well for us.
Awesome. Well, we're at time here, over time actually. So I really want to thank all this whole panel here for sharing their thoughts and being here, and thank all of you guys.